fourth analysis, we have the 1 point first curve, right? It's only for the 1 point. So if you want to get the map, so we get the map. We have two methods. One is every point we get the first curve, right? We get the first curve, one. Then we get the first curve. Then we can get mapping. Also, this method called the first volume, sparse first volume. Then for this first volume is because use the one first curve. It's a triangle shape, triangle movement. So that means it's slow. We want to fast, then we change to the moving to the sine wave. The sine wave is called we call the peak force QM. That's fast. Let's also get the every point the first curve. Just the scanner moving is like this. It's not like this. Okay, so that means for this 1 point. And another one is called the first volume. This one is for imaging. So this is for imaging. We have the first volume and we also have the peak force QM. So where we can find this one? So if you go to this screen, you have the mechanical properties. You can go here. Okay. So for this one, then this one called the first modernization. This one is not for the quantitative the mechanical properties. It's only for the contrast. So compare this material and this material. They only give the contrast. They don't have the quantitative data. So if you want the quantitative data, this one is called the first volume. Then another one is called the QNM. This peak force QM have a different experimental workspace. One have the mirror wheel. So Friday will show how to use the mirror wheel to see then which area or which point. Then normally we use the quantitative mapping. Use the peak force QM in air or in flow. If you use the air environment, you just choose the in air. If your sample must be done by inside the liquid, then you can choose the in liquid. So this all this method is similar. So that means we need the same kind of the parameters. The first parameters is called F equals to the for the Hertz module. So today we are talking about the Hertz module and the Sneddon module, right? Then that's the different applications. Then the Hertz module is for the electric modules, right? Then the Sneddon module is a deeper one, right? It's the harder the simple changes. Indentation depth is deeper. Then for modular for the Hertz modular, then the indentation depth is smaller than the tip radius. So that's the different applications. So from this one, then we know that this I think is one. So from this from R this is a square, and this one is changing. This formula is this morning we gave, right? This is called the Hertz module. Hertz module. Right? This from this one, we know we have the three kind of the parameters we must be know if we want to calculate this modulus value, right? So this is for the F. We are know from the Hooke's law is from the K and the X Then from here is the force, right? This one is for deflection. This one we call the deflection. This deflection we measured on the AFM is from this detector, right? From this detector. That means we should know the force. The force equal to K plus deflection sensitivity plus vertical. Okay, so that means this deflection sensitivity, yeah, this coefficient number, we must be know, right? Before we want to calculate this one. Then this vertical is we can get from this detector. So for all operations, this number it should be the set point, correct? Because the maximum the set point. So this one, that means this vertical is we get the set point. Okay, we use the set point. Then this one we must use the very hard sample to get for. Very hard sample. That's we are talking about the hard sample is sapphire or the silicon. Or if your sample is quite soft, you can use your glass slider. So that depends. And for broker, if you bought the Picoforce QM, we provide one set of the samples. That's called the Picoforce QMK. That's have the two box samples. 哎，那个QMK 来，Okay. Okay. So that means you have two box of the samples. So this is this sample. You have the six.
This is my own.
Okay. Okay. So you can see the inside this box they have 4 sample at here. They code this samples is modulus is already known. Okay, they give the modulus. So that's why we call this one is the standard sample. The at here is a simple one is a 2.5. The Young's modulus is 2.5 megapascal. Then the second one is 3.5. Then this three one is 2.7 gigapascal. Then this one is called 72 gigapascal. So that's for different kind of the samples. We should use the different standard samples to calibrate this value. Okay, we calibrate with this R. Okay, so then we have another box. Then inside here we provide one the sapphire sample. This sapphire can be used to calibrate deflection sensitivity. But this one should be
this one will be dirty, so I make another one.
Okay, should be clean.
Yeah.
Should be keep clean. Then for this sample,
The same.
Okay. So this sample is called for the RS sample. This one is a quite hard sample. This one we use to calibrate the R. Use the relative. Use the not relative, absolute method. This one this kind of sample we use the relative method to calibrate all the R. This one for the absolute method to calibrate the R.
Oh, okay. This sample I already load. Yeah, the titanium sample is already inside.
Already
Yeah,
inside.
inside.
Okay.
This the spare.
Okay. So that's all the samples for the Picoforce QM. So actually, if you is your sample when you bought the Picoforce QM, if you are not HA, then you have 8 samples. If the HA have the 6 samples, so if you have the if your the simple K is not this HA, then you have another 2 samples. One is HOPG, one 8 sample. The 8th sample is for the prepare. For prepare is called high density polymer and the low density polymer mixed together. So we can use that to prepare. Okay, so that's all the for picoforce QM. You must have this kind of the samples. If you want to quantitative your data, if you just they want to compare, so you no need to very how can I say very read the number for the modulus. You can use some data the factory support give you. So that's for example, we have the key, right? So in the each kind of the box, the probe box, they have the key value. This key value is for this kind of the probe. It's not for the each probes. Okay, so that means you can use this one, but not very accurate. So for example, then if you just for example, we use this one. Then we got this one, and we load the experiment. So when you load this experiment, then the first step.你说 What's the question?
Because my sample is softer than PDMS here.
Yeah. Then you can choose the more soft the probe, but the calibration maybe a little bit difficult. Because we don't have the less than the megapascal send sample. The soft one is the 2.5 megapascal. So we don't have the K-pascal.
He said I can buy another cantilever.
They already, they already give you the key and they already give you the key and the R. So if you bought that kind of the probes, you may get very accurate with the data. So we have 2 kind of the probes. So one is you must calibrate yourself. Then for this kind of the probes, factory is already provide you the calibrated data. So this data is include K and R. But this one is they just provide you the total data. Okay, so this one is accurate. I think we already opened another one, right? It's already earned. So how do you choose your probe before you do your samples? Then we have the ruler about how about your samples the modulus range. Then you should choose the different probes. So at here you can know how to choose the probe first. Yeah. AFM. Oh, not this one. We want to do the HEP dimension. Okay. So if you want to find then the detail about the operation, then you go to this HEP. And here you have the imaging modules. Then this one is scanning force. Optical modules. This one. Mechanical mapping at here. Then they told you then how about this picoforce MK include Then we have different kind of the probes. So these probes is for different ranges of modulus sample. Okay, so for example, scan assist air. Maybe you use this one is a soft samples. For 180, it's a little bit harder. Then for the 300, they can get the 2 gigapascal samples. For this 525, they can use to measure then even 10 gigapascal samples. So that's the difference. Yeah, this one is not in this. This is quite special sample. That's special probe.
So can I?
Can.
Say HPI.
Yeah, this one is more hard. This one called the diamond probe. This one for more hard samples. Okay. So for example, even your samples modulus is over the 10 giga, then you can use this probe. This probe is a diamond probe. It's a truly diamond. It's not a silicon probe. So this okay, so you can see another one, right? You can see another one. So this one is already calibrated. So this 30, this number, this 30, this means the diameter is 30 nanometer. So that means you no need to calibrate the R. Okay, so you already provide you the R. Then how do you know? Then the inside the box, inside the box, what the number is here? Already calibrate the probe. You have this QR code. Okay, so this one is where you can find this code the include the data. You go to the setup. Okay, you go to setup. Here have the truth probe, right? So this is the truth probe. If you select the probe, your probe is not calibrated, then you use this one to calibrate yourself. But if you have the code, then you use this one. You use this one. Then scan by this code. So after you scan this one, you can see then the number is listed here. Okay, so inside this one is 1, 2, 3, 4, 5. That means inside this box won't have the 5 probe. Okay, no more probe is have the 10, but this one is only have 5. So include here, they call you, then the key value is first one key value, then the second one is the key value, and another is called the resonant frequency, they also provide you. Then, and the Q value and the tip radius. Okay, so the data is already provided here. You no need to calibrate. Just put this data inside this scan parameters. Okay. Okay. Then, for example, if we use this 1, 2, the second one is the key is 0.867. Okay. So and also this tip radius is 29. Then the half angle is 25. Where we put this data, okay, then we can put this data, go to the scan parameters. Okay, so you see here, we need these parameters to calculate all the modulus value. Then now we know this one is 0.876, right? And this one is 29. Okay, we just put inside here. This one, if we go to the expand module, we can see more parameters. This half angle is 25. Simple boson ratio is 0.3. This 0.3, that means it's give the data. It's not calibrated because it's too difficult for us to calibrate the boson ratio. Okay, so we have another data we haven't found, right? So that's another data is called the deflection sensitivity. Where the data? Okay, this one is called the deflection sensitivity. This deflection sensitivity we should put here. Okay, that inside the detector, calibrate detector, we should put here, but we should calibrate this data for the different probes. Every time you load the probe and align the laser, you should recalibrate this data. Okay, because this one is depends then where your laser focus. Okay, because like here. Okay, then the probe, the probe is like this, right? The probe is like this. If your laser put here or your laser put here, you get a different deflection sensitivity. So that means that every time you reload the probe, you should get the deflection sensitivity, get a different sensitivity. So how do you get this deflection sensitivity? If we go back to the setup, so we have the calibration probe, calibration screen. Here have the non-touch, touch, and advanced. If we open the advanced, okay, you can come back to the probe calibration window. Okay, so this window is have the thermal tune. So if you already know your key, so you no need to thermal tune, right? You no need to do the thermal tune. Then, but the deflection sensitivity, you better is touch on the sapphire samples. Then you get the first curve, you get the more correct the deflection sensitivity. Of course, so also you can use the non-touch things because we already know all the spring constants, right? Then you can put your spring constants. Then if you put here, you also can use the calculation method to get the deflection sensitivity. Okay, so this is the deflection sensitivity. So that means if you will put the data in here, we get the deflection sensitivity is 98. Okay, so this is from the calculation, non-touched, but it's not really accuracy. So more accuracy is you touch on the sapphire. Okay, so if you want to use the sapphire, then first thing is you say here have the use ramp, right? Okay, then you should go back to load the probe, align the laser, put the sample on the track. Okay, let's see where go to where the sapphire. The sapphire. Okay. 现在装个什么针？没装针哈。OK， 这个用这个吧哈。OK， 这个。That's put here. We load the probe. So so we should use which one is the best one? Okay, I think I use the sample. 你没有这个第8号样品。Okay. Okay, okay. Then we just use this 41 40 RA. So this 40 is a little bit soft probe because this one is only 0.8, right? So it's a little soft probe and we load them. So if you want to do the peak force QM, you better use this holder. This holder is a little shorter one. If you have the longer one, because the holder the resonant frequency almost 2K 2K hertz is near all the peak force QM's use frequency. That's why a little bit confused. So we use this soft one. It's a short one. It's a short one. So load probe is quite easy. So you can use the different one, whatever, whatever you, which one you like. Then for the probe, 我就用这个。你来装 ，OK。OK，这个不是液态的。
液态的跟你长得一样。
不一样，不一样。液态它那点，你你这里有液体的碳真甲，他们没有啊。那个液体的碳真甲是一个 plastic 的，是塑料的，因为咱们是要加电的，所以呢，你用这个这是金属的，倒到水里不会烧啊。所以液相碳真甲是一个透明的圆的Let me show you then what where the 我看看有没有啊。Let me show you then the liquid holder 啊，liquid holder，liquid holder，然后 the contact contact image liquid，那 liquid OK let me show you that is around like this OK this is a circle one then the material is the material is a plastic so it's a different kind of right but it's a different it's different like this is a circle one the for liquid 不是这个不是长得像这个
上面也放在黑色的
对一样的就是 you see have the four pins so it's just match this four pins similar OK similar no 那水是这个是碳真甲是要倒过来是这样子这个地方是要保护的它not like this one 那个水是要放在样品上面的so the water is inside it on top of the sample 然后呢盖对它有两种For liquid, we have two kind of method. You can open circle. For example, your samples is when you drop the water on the surface, the water is like the ball. That doesn't matter because the water not drops to everywhere, right? Then you just use this one. Then you can open cassette. But if your samples, when you drop the water, they separate to everywhere. You must use timber. You can call the timber. You can use the glass slider. You can use the like the by left hand they glue the cells inside the bottle. Okay. Then next one is you can drop the water inside. Then this one, then just put inside the box. Okay, so that's one. Okay, so this one. Okay, so they don't have this one, so that's why I cannot show you. This real holder. Okay, so after that, then Orlando laser 这是一个scan ACCR 的天窗。OK，Okay, so other steps is the same. So we just return back. Then we go to the setup. Then we align the laser. Hey, where the camera?
I forgot here.
Okay.
那个
哦，
在胸里面冲突。
So set up and focus on the sample. Every kind of the workspace is same. So you just align the laser on the probe, then adjust then this the vertical and the horizontal signal to the serial. Then see the signal sum is enough. So if your the cantilever is the backside have the coating layer, for example, aluminum or the gold or the something, then the signal sum will be higher. So if you use the probe, it's no coating layer, this sum will be a little bit lower. So it's around the 1 to 2. Then if you have the coating, you can get the 3 or the 4. Okay, so this from the signal sum. Then first one is you should focus your probe. You focus your probe. That means you should align the probe and the engage set point on the sample. Okay. Okay. So loss. Oh, okay. So I know because this box the probe has a little bit problem. The signal sum is a little bit low. We know about that. So okay. So we focus on this one, and this is all the probe. Normally for broker the probe, you put this cutters around this triangle shape. Okay, because then all the probes is here. The probe is not here. Okay. Then you adjust this one to the center. Okay, adjust this one to the center. If you want to use this probe, just you don't want to calibrate the different sensitivity. When you choose this probe, this one is called RFESPA. This one. So when you choose this number, then when you choose the probe, you can see here give the deflection sensitivity number. Have this one. This one just a blah because this number is provided by factory. Okay, so this is not really accurate, but it's a number here. Okay, it's a number here. Then after that, you can return and save this data. So if we want to accurate deflection sensitivity value, we should put the the sapphire, the samples on the track, then move to this sample inside. Okay. Okay, just focus on the sample and come on. Because this sample is transparent sample. So when you focus this one, you may cannot find the surface. That's why use the tip reflection to find the surface. Okay. Maybe already out. Okay, and let's see where the surface. Still not the surface. Where's the surface? Where's the surface? Okay, I cannot see the surface. This one. Here is the surface. Yes. Here is the surface. Okay. So because it's a transparency sample, so it's difficult to find the surface. If your surface is quite clean, you cannot see any particles. Then you use the tip reflection to find the surface more easily because you see then the tip is already there, right? So when you change the sample and the tip reflection, you can see you only change the optical value. It's not the C value. Okay, so that means this one on the same height, the tip on the same height. Answer. So here is the surface, right? Here is the surface. If you use the tip reflection, you see the tips, the simulate images. So this the surface is on the same. That's only mode this camera. They are not the same. Yeah. Mode C is dangerous, but mode camera is not. Yeah, it's not the dangerous. Okay, so these are all the clean sapphire the surface, find the clean area. So if we want to do the touching one, then okay, for calibration, for deflection calibration, you have different method. The first method, you can use this one is touching. Okay, use this one. You go to the advanced. You go to advanced, engage on the sample. So this one called the engage on the surface. Then another one is in contact module. Engage on the surface. Use the ramp to get the one first curve. You also can get the update the sensitivity. So this one is you already know then the tip radius and the tip radius and the spring constants. You just get this diffraction sensitivity value. That's enough. Then you can do your sample. Okay. So if you use the probes is non-calibrate, you must follow the procedure one by one. So first the diffraction sensitivity, K value, and the tip radius. Okay, so so that's a different way, different way. The touch calibration indicator setting is wrong. Okay. So and correct the setting. Okay. What happened? Okay. No setting. This this one is the ramp size. Ramp size. And here you can see the ramp size. Let's see. That's the ramp. Can see then what happened? Oh, okay. So something wrong. Okay. So that's why we cannot see then the first curve. Okay. Spring K and different has not initialized. Go to a new diffraction sensitivity. Oh, what happened? Okay. It's drop. Oh, what is it? Look. Okay. Surface. Okay, I think then I think the laser position is a little bit odd. Little bit odd. Then I'll go back to the surface. On这个真有点不同。touch of surface surface. OK， 哇，好脏啊这里，难怪你 OK。比较干净，这里比较干净一点。Yeah, let's see. 这为啥？它什么叫 surface 啊？ Let me do the thermal tune first. 不要读这么清。Calibrate the data. Oh, okay. So the data is lost. That's why we cannot get the data. The data is lost. So the before the data is 122. Okay. This one is before the data. Okay. Then we go to the advanced. Then we touch on the surface. Engage on the surface. So normally we put the laser a little bit inside, not on the top, very top one, because the top one is narrow. Then the laser reflection will be not very good. So that's why we put the laser around this set. 哦，一个。我搜死了。怎么这么慢？你这个怎么这么慢？
是很慢的，但一两个是
它的
CC 问题。后面上你看那 motor 刚刚嘛。
我就说你这个好慢啊，好慢。对。应该不至于。
是啊，是不是设定完
？OK。但 normally 你用其他模式也更慢。
不是先哪些省快，就是那个就会特别慢。
OK。
那是不是导播的真实也特别杀的慢
？OK， 因为有可能。这怎么下不到呀？怎么这么慢呀？
那 motor 在动，
没有不动，motor 没有动。OK。那 the motor 已经到了，没有响啊的。OK， 等等啊，我看一下这个，我把这个增大一点，然后这个，然后 then the ramp， simple ramping。OK。OK。So after engage on the surface, you just then use this ramp. The ramp means the probe is from far away to near the surface, touch on the surface, then withdraw. Okay, so that's one is the first curve. We use this set to get the calibration deflection sensitivity value from this set. Okay, so after that they give you the data at here already. Then if you use this data, you can just update the current sensitivity. Okay, just update the current value. So this value will be read to insert the calibration. Then you can return and save update value. So if you need to do the QNM, you should do this one also. Okay, so that's the data is at here. So they already update the value is here. Okay, so after this value, if you want to do the QNM also, then you should calibrate this synchronous QNM. This one is the same. You engage on the surface. Same thing. Same thing. Another thing is you should careful is which kind of the frequency you want to use to do your the peak first QNM. So you can choose the frequency. Normally we use the 2 kHz. If you need the do the very large cell or something, you need the slow one. You should calibrate the slow frequency. Okay. 真的是好慢 ，OK， also someone want to know the amplitude sensitivity. At here, you can sometimes to get the amplitude sensitivity also. At here, they have the more settings called DDS3 is also calibrated here. Okay. So after that, then you come back. Okay. So if you do the calibration, you see this will have the more settings. So at here, you can choose which frequency you want to use. Then do the frequency. If we do the 2 kHz, we just use this calibrate, then do this one. Okay. So they provide the kinetic distance mu and the peak force amplitude sensitivity. So after that, you also need to update and verify the current value. So you can after engage this one and this one same times to do the calibration. Okay, so that means you do this one and do this one, finished, you return and save. Okay, you can return and save. They will withdraw them from the surface. So this software is used and finished. You can take out that. Okay, you can take out that. Okay. Okay, so that means this software is used. Then from here, we already know then the diffraction sensitivity K and R, right? All these three ones. So if you just want to see then the data in the contrast, you no need to really accurate the data. You can the diffraction sensitivity, you can use this data. Okay, then K. This is key data. You can the key data you just use this in on the box value. Okay. So for example, this one on the box they call the 0.9. Okay. Then this R we don't know this R. Then this R you can find in on the broker's probe website. So the probe website give the all kind of the cantilever, the R and the height, the data. Okay. Of course, then the accuracy will be lost. The accuracy will be lost. So if you probe, they don't have this calibrated data. Okay. You should calibrate diffraction sensitivity is the first. Okay. So after that, withdraw. Here have the thermal tune. Okay. This one, thermal tune is for key calibration. The key calibration have a different way, right? We have the different way. So after deflection sensitivity, the first one. Then the second one is the key. Key have the two methods. One is called the thermal tune, right? Thermal method. One is called the SED method. This one normally we use, right? The SED. So for the thermal tune, normally we use this method for the K less than the 1 Newton per meter probe. Then for SED method, we use the K larger than the 1 Newton per meter the probe. Okay. So for thermal tune, it's quite easy. Okay. So you just withdraw the probe from the surface. That must be withdrawn far away from the surface. Then use this one is called the thermal tune. Then at here you should choose then the how about the range of the frequency range. Because then the different samples, the range is different. For example, this samples is 40 kHz. 40 kHz, we can choose 100, 1 to 100 enough, right? If your sample, if your probe is 300, that means 100 is not enough. We should use this longer one. So if we use 1 to 100 kHz, you just acquire data. Okay. Okay. So during acquire data, never abort this process, because if you abort that one, then they will induce then this PC down. Okay. So this thermal tune is also find the probe's resonant frequency. The resonant frequency have a lot of the one, right? Because then when one thing is damping, the frequency have the first order one, second order one, not a lot, right? So we just use. Then, okay, so we find this this peak. After you get this peak, you can use a control. You can use the control button, then the zoom in inside this peak. After that, you get the fit data. Oh, okay. We need to make markers. Need the cursors the beside this the peak. Then you just fit the data. So this fitting should be the measurement and your method your method formula should be the fitting very good. Okay. Then you can get the deflection sensitivity by thermal. Okay. This one is we get the data is 106. It's almost similar we get from the factory, right? All the similar. If you use this value, if you want to use this value, then you can go to the yes. Okay, you can go to the yes. So after you get this sensitivity, the key by thermal. 为什么不能 key by thermal 啊 ？You want to use why the key by thermal? Is the key by set key by thermal? 为什么你这个不能 key by thermal 呢？一般是it should be the key by thermal. 它可以这样
Yes.
We already have this data, right? Then we should check it. That's check this. What happened? What happened? What happened? We cannot keep back so much. Mm-hmm. 它这个出了什么事情？奇怪。真是奇怪了，这个。Keep by set or the key by thermal. Okay. Oh, what happened? Oh, okay. Then, okay, let's draw this one, the cursors, then the fit data. Okay, so after the deflection sensitivity, you got the value, then you can use this thermal thing to calculate your key. Okay, so this one have the key by thermal. So you see then the key is around 0.88, right? Is near all the value. So if you got this data, you can get the yes, then just return. Okay. Okay, this one is for key calibration. So key have the two methods. If your key, if your the probe is a triangle shape and the key value is bigger, then you can use the set method. So the set method, you if your phone is an iPhone, then you just can download that. Download that. Then that's I can show you this one. Okay. Set method. 对。So if you want to get the set method, have the two parameters, you must be know first. One is the frequency, one is the Q value. Then that's the two parameters you can get from just not the thermal tune. And also you can get from the typing module tuning curve. Okay. from here. Then if you go to the typing mode, 哪一个 ？typing mode 哦，here 啊，对，啊，OK 啊。Okay, so in this typing mode, the workspace here have the tuning curve, right? The tune the cantilevers, the one. Then after you get this one, you just auto tune. You just auto tune. Then you can find this peak, right? This resonant frequency for this cantilever. Then after that, you get the resonant frequency value. And also you can get the Q value. The Q value is from here. So use compute Q. You will get the Q value. For example, this probe, the Q value is 95, right? We can record this 95. And also the frequency is here. It's 44.88, right? Okay. So if you got this one, then go to the set method. So in this set method, you also need your box. Okay, you also need your box. So you choose this set method rectangle cantilever. Okay, just select the rectangle cantilever per size. Then put the length. The length is around 225, right? Just put the 225 here, 225. Then the width is 40. Then the frequency, we just get the frequency at here, right? So it's 44.88. Then this Q factor is 95. 95. You just get this data. Then at here have the calculate. Okay. So you just clear the calculate is give you the 7.26. Okay. So this key value is 0.7. Then the box give you 0.9. So that means that for this probe it's 0.7 only. It's not 0.9. So you got this data from these two methods. One is thermotune, one is the set method. Okay. So this is the key. Now we only have the one parameter that should calibrate. It's the R, right? It's the R. So the R is a little bit complex. So tomorrow I will show you how to calculate the R. So today I will show you how do you get the first curve first, because then the first curve is the basic of the to calculate the modulus, right? Okay. So at here, we go back to the basic one, huh? So for the first curve, we have two methods to get the first curve on this screen. The first one is a contact model. Okay. For example, I put one sample on the here. Let me change the sample. I change the sample here. I take out this one. This is sapphire. Okay. Then we get out this sapphire and the two percent. This one. So for example, this one is my sample. Then I just put inside the this one. Oh, okay. Here is my sample. Okay, here is my sample surface. Okay, so we have two kind of the method to get the samples, the first curve. The first one is we cannot use the typing model to get the first curve. We can use the contact module and the scan assist module, two methods. Okay, so for example, if we get the contact module, you just choose the contact module in air. Okay, you just engage it on the surface 0.6. Okay, 0. Maybe 1. Okay, let me engage it on the surface. So for contact module, the set point, the deflection set point is the force to engage on your samples, and also scan the sample use the same value. Okay, so you already engaged on your surface. If you want to scan the image first, here you can give the image at here. Okay, so we get this one for the imaging. If you want to get the image first, then you can from top to down to get one image first. If you just want to get the one first curve, doesn't matter, you just ramp at here. Okay, so for example, we ramp this one. This one is stopped on the middle of the 5 micro the scan area. It's only on the center. Okay, if you want to ramp, you see at ramp the screen, you have the ramp output for the C. All the first curve is the C and the deflection, right? It's a deflection. So if you get this first curve first, you see this one is C and the deflection. So this one, let's capture this one, huh? So you can see this one is a lot of the variation. That's the variation comes from this laser. Okay. So that means that here have the interference, laser interference. If you want to reduce this one, this laser should be a little bit inside. Okay, adjust the laser inside. Yeah, and also you can reduce this one. For example, I can reduce this one. So that's a little bit of flat, right? A little bit of flat, then it will be less than the interference. So after you collect this one first curve, it's only in the center. Which kind of the area you don't know, right? You don't know. So have another one is you scan an image. You choose which point you want. Okay, so that's called the point and shoot. Then we go back to the scan. We scan an image first. So we get the image. So when you scan this image, if you go to this area, this one called the point and shoot. If you clear this point and shoot, the image is also shown here. Okay, so at this area, then you can find is a ramp with a current image or the ramp with a next capture. So if you want to use this image, I already see the image. You use the current image. If you want the full image, full image, you can use the ramp with the next capture. Then you from the top to down scan another image. Okay. So so here I already get some image, huh? Okay, so I don't want to waste more times. So I use the ramp with the current image. So the probe will be stopped on the middle. Okay, so this red circle is all the probe position. Now the probe position. If we use this mark, then we can choose here, here, or here, or here, or here. Then the marker is you choose the which position you want to get to the first curve. Okay, so all this the point we use the same parameter, ramp parameter. So if we get this one, okay, then we use the ramp. Well, what happened? I think what happened is 他们这个怎么这么差呀？这个现在，what happened 呀？对，我觉得他们的机器好像有点问题。对，ramp is current image. Okay. 啊 ，OK， 可以。1, 2, 3. Okay. So ramp and capture, you will get these 3 points first curve. So which one is which one is in the which position? You use this file to open. So you open this file. You can see the first curve at here. So we have the 3 points first curve. This depends then the colors. So which color? One color will be fit to the one color. Okay. So this cursor's color. If you want to only see one, then you can see this color is the middle color, is the blue one. Then if you want to add another one, then this red color one is the second point. Okay. So this one is how to you collect the first curve. It's a 2 method. One is a single point. One is the point and shoot. Okay. So this one is in the contact module. In the contact module, after finish, you can go back scan. So in the point and shoot window, you must go back the image scan first, then before you withdraw. Okay. So this one is this one in the contact module, because all of no, then the contact module that the image is a little difficult, right? Because the sensitivity have the lateral force, so the sensitivity will be low. So if you want to use the other kind of the method to get the first curve, we can go back to all the scan assist or the QNM. Okay. So all the QNM, inside the QNM, you also can get all kind of the first curves, all points the first curves. So let's wait. Okay. Oh, why so slow? Okay. So at this pick first QNM, then at here you can setting your parameters first. The first parameters is engage setting. Go to the engage setting. At here you can choose the peak force amplitude. Peak force amplitude, and also you should set the engage set points first. Okay, so this one is different with the peak force. This one is the engage force. Okay. After you setting this one, for example, I want to my sample is soft. The smaller amplitude may not be enough. I need a higher one. Then I can change this one to the higher. Then after that, this one is 100, and also I change this one go to the 100. Okay. I can engage on the my symbol. At this set, we will show you each point first curve. So this one is each point first curve will show at this real time. 喂，啊，请讲，嗯嗯嗯。你就跟我说吧，你加我一个微信，我一会儿把信息你发给我，你的姓名、电话、邮箱、单位发给我，然后呢，想要一个什么样子的那个什么，然后我到时候再跟你联系。啊，我姓王，啊，嗯，对，嗯，好嘞，好，OK，OK，好，啊，拜拜，嗯。So you see, this one is called the first curve. The first curve. This one is called time and say, right? But you see, it's a lot of noise, right? A lot of noise. The reason is this laser. Okay, the reason is this laser. So you see here have a lot of interference, right? A lot of interference. So we should optical or optimize all the laser position. Okay. 好, then how to you optimize your laser position? You just go to here, go then use the tip reflection to see where the laser. Okay, and the laser maybe a little bit inside. Okay. Go to the surface. Then this the vertical and horizontal. Also should okay. Okay, that's it. That's engage again. So you can see at this this screen, we have the auto configure and also have the capture lines and the update the sensitivity. All the functions can be here also. Okay, so for the sensitivity update, you also can be done here. The first curve. The first curve 咋这么差呀？Auto control 啊，the force is 哎，我知道是哪里，但是它的力不够。So the engaged site this one is too small, so we can say. 么大的啊？我等一下。这么大呀？我想想。喂，嗯，哦，700多，你700多肯定不正常啊，要不然你的蓝宝石有问题，要不然就是你的操作有问题。都下不来了，那不可能，你操作哪里有问题了？对，不可能，一般的情况是探针长度的一半儿。嗯，你是 engage 到样品表面了吗？嗯，engage 到蓝宝石的表面吗？没有，你是到 ramp 里头去啊，你到 ramp 拿力曲线呀、从力曲线里面才得到那个 diffraction sensitivity 啊。啊，你的力曲线正常吗？先看看力曲线正常吗？那你的数据太小了，你有可能你的数据太小了吧？正常。嗯，你的 ramp size 改呀，改 ramp size 啊。嗯，ramp size 为什么下不来针？你稍等一会儿，我这上课呢，我上完课再给你打啊。哦，对啊，换个位置，这个位置，哎，下不去针了，下不去针了。地图，我们地图下不去，都大点力，都这个是放0.15连的大点吧，100。OK，反正这个针不太正常啊。感觉是这个针不太正常，真的。这个 parameter 咱这边给100，100，100，下不去真的咋？So for peak force, for the peak force module, they have the peak force typing control and also have the cantilever parameters. So this peak force typing control parameters is depends then the samples you should adjust. Then sometimes if your sample is soft, then your frequency maybe should be less. Then also this peak force amplitude depends the samples you should set. So for example, just I use the lower the amplitude, cannot engage on the surface, but now I can engage on my surface. But this okay, now is good. Okay, first thing, what happened 呢？你的看图结果怎么这么差啊？哦， I know what happened. Okay. Because I didn't hold the sample. Hold the sample tightened. Okay. Let's see. And can engage on the sample surface. So at here, this kind of the parameters is for the engage on the surface and scan on the surface. Then these parameters will calculate the modulus and indentation and adhesion channel. So this one is for the first curve, this for the first curve show the every point the first curve. 你觉得这个真的是有点问题 ，OK？ 你看 this first curve is not very good, OK？ Now so this first curve is not very good, OK? So now the surface, we already engaged on the surface. So if we got the 5 microns the scan area, when you see this image, 这个真的是有问题啊！这个真是有问题的针，你发现没有？那这个真的是有点问题啊！这个 first curve 的是不正常啊 ？OK， 不正常，这个 first curve 怎么都不正常啊？我先回到这边来，大点力试一下。邪恶。OK， 我大一点力，我下针大一点力 ，engage 在点灯的150，再大一点。Then change this one to the standard engage. OK， 150。下不来呢。What happened this sample? OK， 这个针真的不行，换一个针吧。OK， So this probe gets some problem。我们换一个70的针吧，换这个70的针。你是有新的针吗？还是？你用这个新的吧。对，用这个。OK。So the probe gets the problem you can not engage on the surface。那我去个洗手间去。OK， so this probe is quite good. OK， Okay, let's see, then navigate. Okay. Okay, so so let's go to the pick force typing. Then even in the scan assist module, yeah, in the scan assist module, then we got the engage on the surface. Okay, check engage on the surface. Then we also can see then the each point the first curve. But in the scan assist module, we cannot collect the each point the first curve. But we can use the ramp to get the point you want you want to default the points the first curve also. Now looks good. Okay. Not the first curve looks good. Okay. So the proof is quite difficult. Okay, so at here, if you use this red the red one, yeah, on the mouse, you can use the undocker, then the C, then the first curve, and the C, the fourth and the C, and the tenth curve together. If you don't want this one, then you just then the right click, then the docker back. Okay. So at here, you can change the first curve and the head first. Okay. So at here you can see this vibration. This vibration comes from the environment. Okay. So because they didn't use the vibration table, because you see yes, but still have a lot of the environment with the vibration. Okay, so this is the force. So this is the first curve. We cannot collect each point in this module, but we can undocker this one. Here have the capture lines. When you scan on this one line, then you can just capture all this the first curve on this scan line. Okay, this one called the high data speed capture. After that, you get the first trigger. Okay, capture lens. Okay, I'm sure. Okay. Okay, then we should can see then the first curve. Okay, then we talk back. Then we can see this one. I can come back. Now, so this one called the line capture. Then you can see on the one scan lines, then how many the first curves you get. Okay, so this one today we are talking about the scan, the peak of the typing is one jump to another, jump to another, right? Then all the points, these points, we get the profile is all the simple variation, right? So that's why you can see, then this one from this one line, this one is higher, this one is lower, right? So this one is the whole movement on all the surface. Okay, so from here you can see that. Then at here you also can see then all the scanner is the vibration, scanner vibration on the surface. Okay, so for this one you get the first curve, you get all the first curve. At here you can use this one to retract all the first curves you collect on this scan line. Okay, so for example, at here, I can see then all the first curves at this side. Okay, you can use this one. For example, I use 100 to 100 to the 100 1095 one. All the first curve here. If you export this curve, that's one each point the first curve will collect. Okay. So this is one method to one time collect more first curve. Okay. Then another one is the same thing. Like the ramp. The ramp. Then this ramp is a single ramp. Then whatever just in the middle, you get the one first curve. Okay, you just can capture this first curve. At here, if you use the extend module, you can see here have the XY scan. So this XY scan is under this area, your scan area, you can set more data points to get the first curve. For example, I get the 2 by 2. That means I have four first curve, right? I get the 4 first curve. So 1 point to 1 point, you can give the distance. For example, column to column, then only 100 nanometer difference. So you can see at here, you can setting. For example, I give this one is 200. So if you use this one, then use this auto ramp, they can one time to collect then all the set points you want to collect. Okay, so now you see this X offset and Y offset, but in the which material we don't know. So if you want to know which material, you have to use the point and shoot sensing for contact model sensing. Okay. So this one is you got the first curve. Then you can analysis single points the first curve. So for example, this one the first curve we collect, right? So if you want to analysis this one, then at this analysis software, the first things they have the baseline alignment, right? They have the baseline alignment. We can calculate this one, get the baseline alignment. Then we use the baseline alignment. So when you use the baseline alignment, you will see this one change to the separation. So this separation means is reduced then the deflection, how can I say, let me see, then this one is C equal to the indentation depth, plus then the deflection, right? Deflection. Then after the separation, they use the indentation equal to the C minus deflection. So at this separation, we already subtract the deflection. So so on first curve, if we use a first curve, okay. If we see the first curve, then first curve deflection and separation. First curve C separation, deflection, and for deflection. So this one is the normal first curve, right? It's the C and the fourth. Then if you want to see then the reduce the deflection, then use the deflection and the separation. The deflection separation. Then this one. Then we go to the separation. Separation and separation. Deflection and separation. Okay. Deflection and the separation. Separation and time. Eh? What happened? Center. So we change it to the separation and the force. That means this point is on the deep is the point. Deep is the point. So if this one is the direction is only the line, right? It's a straight line. That means no indentation depth. That means your probe cannot push inside your sample. So your sample no any changing. So if you find like this, if you find the curve like this, you cannot analysis the modulus because no indentation depth. We do the indentation depth must be follow this one. Then the force equal to the F the delta. That means is your sample if no any change, this one is a 0, then you cannot get the modulus. Okay, so if you find like this, you first things think about then your calibration is correct or not. Okay, calibration is depends then the deflection sensitivity, right? So your calibration deflection sensitivity must be correct. Okay. So and another thing is your choose the sample is hard enough or not. If not hard enough, that means the sample is too hard, then your probe you cannot get the indentation. Okay. So from here you also can analyze that. For example, all this for this probe is a little bit harder, right? Then I can use my probe the parameters to change this one. So for example, this one is my first curve. This one is my first curve. If you calibrate my probe first, like calibrate my probe, the probe the parameter should be right here. Okay. After you get the first curve, you can recalculate your modulus. Okay, so that's why we want to put the raw data first. Then you can calibrate your probe. Okay, if you get your probe, so for example, this probe is 250. This one is around 100. So I get this one is 2. Then this one is 20. Then this one is 80. Then this one is 0.3. Then this if I assume this data is I calculate calibrate my probe. Okay. After that, then I can use the new data for this first curve. Okay. After you get this data, you can get the indentation depth. Indentation depth. The indentation depth is from the deepest point to the bottom, right? To the flat area. To the flat area. So that means use this one. My indentation depth maybe from here to here. Okay. Then I change to let me see. Okay. What this number? This number is around here. Okay. So it's around 10, maybe 5 nanometer. Okay. So that means my indentation depth is around the 5 nanometer. So from this point to this area. So that's my indentation depth. So it depends. This depends. For broker, think about this retract curve. Then we use the retract curve to see the indentation depth. Use this baseline. The baseline not correct. Okay. So I do the baseline first. Do the baseline first. Baseline first. 这是 first curve, do the baseline first. Do the baseline alignment first. The baseline. 为什么这一直是 separation? Okay. So I do the baseline first. 这个 baseline 为啥拉不平呢？啊，这 baseline what happened？ 你这个 software 有点问题，怎么 baseline 拉不平啊？看我再重新开。哎，这什么事儿？换一个。Then let me change it to the another one. Okay. Then change it to another one. Okay. Then let's do the let's see then how to analyze the first curve. The first thing is use this baseline alignment, then the collect baseline. Collect the baseline, then okay. After you collect the baseline, you use this one. This one is provide the parameters your calibration. Okay, for example, this probe is L is 200, 100, and this one is the 2. Then this one is give the 20. For example, then this one is 0.80. 0.3. Okay, then let's see. Okay, then after you collect this baseline, this one should be on the zero. This one should be on the zero. Then go to the indentation depths. Then if you go to the indentation depths here, you can choose the Hertz modulus or the Snelling modulus. That depends the indentation depth. Okay, indentation depth. If the indentation depth is quite bigger, for example, 100 nanometer, then 200 nanometer, that you should choose the Snelling modulus. Then if the indentation depth is quite small, you can use the Hertz modulus. Okay, you can use the Hertz modulus. Then let's choose this retract baseline. Hertz 模型，然后duration retract baseline. Okay. OK， 好，应该自己，这个力曲线一点都不好，但是都没有压动，好像，然后是这个没有压动，我再重新给一下，都是它应该是一样的，我们用的是红色的，我们用的是红色的，对，我们都是用的红色的 retract，OK， 2，这个0.3，对，怎么搞的这个 indentation depth OK， 现在应该可以了。Because just now we don't have the indentation depth. Okay, then that's the snake Hertz modulus. Okay, Hertz modulus. 它的 software 里面为什么没有这个 contact point base contact point only 2.5 Hertz modulus. Okay, then this one gives the 90. Then this one is 30. Okay, 30. Okay, so when you get this curve, you can see this one have the green line. So this green line is simulate the formula. Okay, so this red color is your measurement. The green one is the formula. Okay, so if you use this one to get the fitting this green line to the measurement data is the red one. If you fitting this data to get the fitting R square, it's quite higher, maybe larger than the 0.9. That means the fitting is okay. Then you can get these points modulus. They provide you Young's modulus and reduced modulus value. This one is for 1 point. Okay. So this 1 point is you get the first curve first. You can read the calibrate your probe later. Okay. So that's my that's the procedure for the first curve. Collect the first. Okay. So collect the first curve. Collect your first curve. Collect your first curve. So you collect your first curve have the two different method, right? Different method. Contact module can get the first curve. Okay. Then the ramp. Okay. Then another one is the scan assist module, right? Scan assist. Scan assist. You also can use the ramp or the capture line to get the different points the first curve. Okay. Then after you collect this raw data, then you go back to calibrate your probe. Calibrate. So calibrate the probe. Then first one is use the sapphire. THE, right? THE. Use the sapphire sample to get a deflection sensitivity, right? Deflection sensitivity. Then use the SED method. SED or the thermal tune. Or the thermal to get the key value, right? Okay. So this is the third one. Then we should get all the R. Okay. So for the R calibration, we have two kind of the method. The first one they call the for the R the calibration. Then they call the relative one. They call the one is called the relative. The second one is called the absolute. So for absolute method, we use the sample is RS sample. We use the RS sample. Then we should use the RS sample to measure one image. Okay. So this one is the sample is called the RS. Okay. Inside this box called the RS sample. This sample. So this one is quite hard the sample. So when you scan this sample, you must scan the area. The area is 3 micro by 3 micro. 3 micro by 2 micro image. Okay. So when you scan on this sample, you can use the peak force QNM. Peak force QNM. Whatever in the even the typing module you can do. Okay. Collect this image. After collect this image, then you use this one. This one, the image one. Then the image we go back to the image one. So for example, I collect the image. So at here have one functions called the type qualification. We must open all the images at here. Then use the type qualification functions to calculate the type radius. Okay. So when you use this method to calculate your type radius, because the AFM probe is normally like this, right? It's not a ball, right? It's not a ball. So the R is depends then the depth. The depth. The depth is different, then the R is different, right? So we must know on your sample, the indentation depth is what number. Okay, then put the number to the analysis. Maybe tomorrow morning I will scan the sample and open the image to show you how to do the calculation. Okay. Then another method is called the relative. The relative one is use the standard sample. Use the standard sample. The standard sample is depends then the which one. So for example, if you want to do the very soft, you may use the simple one, the number one, number two. Then if your sample is hard, you may choose the 3. If you very hard, you may choose the HOPG. So that depends the which one is you should choose. Okay. So put the sample on the put the standard sample because this modulus is no. The modulus MODU. The modulus is no. Then use this modulus to adjust the R. Adjust the R. When the value, the modulus value is equal to the value on the box. On the box, that's R is the relative method. Okay, so that's the R is the two method to calibration. Okay, that's how to do that. Then after this, the R is already known. Then we can go back this software. We can go back this software. 这个对。We can go back all the software, then put on your sample to measurement. Then you get the modulus image is you want. It's clear. It's clear. Okay. Three parameters only: deflection sensitivity, K, and R. It's quite clear, huh? So tomorrow we can one by one to calibrate the R, then use the different method. Then we use different samples, we can do the demo. Okay. So if you have your samples, we can try also. Tomorrow morning, morning time. Then after afternoon we have the workshop. Then you can attend the workshop to see then the different machines, the applications. Then Thursday we also have one day to do the complex first curve. Okay. So have other questions about that? PDMS we can use the SLR 可以啊，这个就是 PDMS。
我那是做参杂。
你是做参杂了啊？你参杂很重。
就是力学性能也和 PDMS 差不多。
OK， 那we can use a simple one。
OK。
use a simple one to。
如果说最后做的直接把它 coating 到那个玻璃片上，怎样？
粘牢。可以。Okay, so. Okay, so tomorrow we have time to try different kind of samples. 硅片上镀膜啊，看你镀个厚的膜。700纳米 OK， 就So for the first curve or the QNM, the theory is your probe can change your samples, shape. So if the probe is quite hard, that we cannot use the pupil. Okay. 就是 针要比东西硬，对，针要比东西硬，也就是说，你能够用你的针压出你的样品的形变来，它是弹性的形变，但是不能说像压个洞的那样的那塑性形变不可以，因为咱们现在适合的范围，so 的 QM 适合的范围就是能够压出这个德尔塔来，能够压出这个德尔塔来，但是还可以回来，不能压个壳。不能把它成为塑性形变，压完了这个洞回不来了，不适合这个。
只有如果要0.5或者要1纳米这样够了。
1纳米不够。
如果要你再给多也没用，没变化
那就不够。
还是真的问题。
是真的问题。咱们是要求这个德尔塔这个形变样品的 simple 的形变 simple 的 changing 必须要大过4个纳米。OK， 我们就适合这样子的样品就可以。
和那个样品的高度本身没有
样品的高
起伏，
如果你的起伏比较大的话，这个样品起伏比较大的话，就会造成某些点的力度特别大。
就比如说像那个牙刷似的，就是刷头，它那个一根一根的那种。
纳米棒。
那个纳米棒，纳米棒应该是能测，应该是能测。
高度都比较高。
那我就只能看到一个上面的这个，你不能把它。如果你这个深度，在 AFM 都我们的这个AFM scanner 这个 scanner 的这个的 AFM scanner then the maximum 的 length 是10 micro OK 是10 micro 10微米。So if your sample is like this, it's over the field of the micro, it's quite difficult. 超过了10个根本就不行。就是这是我的 AFM 的 scanner 对吧？我的这个能够伸最长的10个微米。那你不能让说我的 scanner 我要在这里。我使劲往下，使劲往下伸呀，把撑10个。normally 我们都是这样子的，我们都是这样子，我往下撑 ，OK， 来，我撑5个是没问题的，对不？我往上再抬一点，我再撑7、8个是没问题。你超过了10个，到了超过了我的高度了，我抬不起来的。所以如果你说的你的那个橡皮瓣都超过了10个微米，对。
那我这个要是纳米，
你要还想要纳牛的，年复利 never mind， 年复利 never mind， 你这个针，但是你的图是导不了的，你超过10个，我图是导不出来的。你一个点可以。
那个纳米棒放上面是不是你要想做那个3维的高度打不出来了，就只会达到10米的高度。再针是
进不去的。
3维图只会。比如你要纳米棒，单根纳米棒甚至超过10米。
对，
但是它会弯，比如说像这样的，然后它是打到了，然后它会弯。
那你测的就不是它的硬度了，它是弯曲，这个是成弯曲。我们现在是让它在这个方向上的形变，你那个成了弯曲的那个了。你要想测粘度，整个的这个粘度，你表面图你都做不了，你怎么做粘度啊？除非你说你的如果你的这个样品是这个样子，就是这上面有一个蛮大的，一个蛮大的，然后我就把针下到这一个上面来，测一个力曲线 ，OK 的。
但是老师有在那个上面能够看出来它的这个大小，就是能够分别出来。
你说 optic 现在是对，它这个我这个方向上 never mind 嘛，你现在是说这个方向上，我看不出来的呀。OK，because he wants the vertical direction for vertical direction， you cannot see because this one is optical, then from top to down.
但是我这其实很前面的其实也有这个，
你说
相当于是这样竖着的这些小的针是这样，然后老师你给的建议是说就做一个，
对，就像这样子，你的就在这个地方，假如说这是你的，我就下针下到这一个上面来，我不扫图。We just engage on this point. We set the scan size to 0. We just engage on this point. Then we can ramp one first curve, no problem.
这个是测算是跟结构有关，还是跟这个材料有关？就如果我换结构的话，这个但同样的材料的话，但是数会差别很大吗？
应该不会。就这个 modulus 这个杨氏模量 modulus is only related to the material, no shaping. So if the stiffness is related to the L and W and L and W, right? Geometry. Then, but the Young's modulus is already separate from the stiffness. It's only related to the material, no shaping relation. Adhesion force is different. Adhesion force from this one. You just check this point and to here. Yes. It's only related to the contact point. Contact point. 你面积大 adhesion 就大，面积小 adhesion 就小。它会和材料有关吗？你这个底下的 adhesion 大，就跟咱们的那个粘胶一样嘛。如果你是那个粘胶，你这么大的，你这么贴很容易，对吧？你这种小小的。你的 adhesion 就小。adhesion force is different. adhesion force 我们不去 calibrate any kind of the probes parameter. You just get from
当时算那个模量的时候，是按单个曲线做，就是软件有没有批量数有？
有啊，
是我直接拿过去做 mapping 的话。
它那个我们有一个 toolbox 可以一次处理多个 workflow。
是再给你另外一个。
我可以给你那个 toolbox 那个 toolbox。另外我们这边也有一个那个处理功能，这个，对，这个this one for 那个 patching 这个是处理挺处理。我们离线讲过啊。我们被这个 training 的时候离线讲过啊。
每次我参加。
OK， 这个有讲过的啊，你看so for example then 这个我们把这个这个 close all close all。Then the first thing 是你you need to do the one template, right? Then you do template, then the flatten, for example, flatten. Then you do the roughness analysis. Then you go to this patching. Then this patching you add all the images you want to that. And you can do the same. Okay.
算模量
一样的吗？But your the first curve must be the similar. OK。
如果差异性比较大的时候，
差异比较大，你就得分着来。你不能说这个压在这个硬的，这个压在软的，这样就可能不该的because the modulus is different。对，
就是说像做那种抑制材料，复合材料的话，它如果两个分的 模量差距比较大的时候啊，我就得单个做。
只能做准一个，就是 if your material is have the a few of the components. So for example, your sample is like this. Here is hard, here is soft, here is maybe iron. Okay, iron. It's iron. This one is a polymer. Then this one is copper. Okay, so this one is quite hard, right? This one is quite soft, right? Then when you choose the probe, you choose for this one is fit this one or fit this one. So that means one time for more components of material. For one thing, one time do one accuracy.
我说的，我先用那个硬的针做完那个 calibration 之后，我去扫硬的组分。我硬的组分的模量从这个图上出。然后我再换软的针，然后再做一次 calibration 之后，我扫完之后软的组分第二个图。
You cannot one time to cover all things because different probes. The key is quite important to the probe. Okay. Obviously. Okay. 还有什么问题？暂时没有哈。So tomorrow morning we are start from here. Okay. Okay.